Assalamualaikum and a very good day. In this video lectures, I will like to explain the one that I skipped before, which is what is the difference between a computer vision image analysis and image processing. Okay, so in this video lectures, I also will explain this instead of explaining these three terms. Okay, computer vision, image analysis, as well as image processing. This is also this discussion also involve as well our recent area, which is artificial intelligence or deep learning, and how does that relate with image processing. Okay, before that, let's go through back what does the image processing cover. Okay, this one can be seen in our, I think, last slide. Okay, the last slide, we can go to the last slide, which is this one. Okay, this one. Okay, this is the actually the several main approach or main component or main technique that will cover in image processing. Okay, but okay, to know more about what does things that will cover in image processing, let's refer to this poster. Okay, this poster is designed by I have designed, I'm the one that designed this poster. Actually, the purpose of this poster to give some rough idea what things we be taught in or will be learned in image processing. Okay, as you can see, okay, it's consists of several main component, which is similar to this slide. Okay, the first block there is about the image acquisition, which is our first chapter. Okay, and we talk about, of course, we talk about how does, what is definition of digital image. Okay, how the the characteristic of digital image, and actually the image acquisition is the process of converting the analog image into digital image. Of course, the analog image is come from the environment, and then you need to have some imaging modality, such as your digital camera or your medical image modality like CT scan, X-ray, MRI, and so on, where this is the hardware that we convert the analog image come from the environment into the digital image. Of course, if you again, like I said before, due to the faulty or defect in your hardware, the obtained image might be have some noise, or maybe the produced digital image is very poor and bad to be diagnosed or to be observed by radiologists. So it's very hard for radiologists to make a decision, which is why the next chapter, the second chapter that we taught in this image processing is image enhancement, where image enhancement, for example, if you see in this one, okay, it's very hard to see there. Okay, there's some noise there, the very dot that you can see, there's like a dot noise in the image. Okay, through by learning image enhancement, actually the purpose of image enhancement is to process the image by using a suitable approach or suitable technique, and then it will remove the noise in general. So you can see that this is the same image as this one. While having the, after applying the image enhancement, it will improve the image a lot. Okay, by removing the noise, and also, you know, remove all the unmeaningful information and retain the meaningful information. Then you manage to obtain the good image, where it's good for the radiologist to, you know, to diagnose something. Okay, I just give you in this example, we just give you some idea, where we just put some example of cross section of cross section CT scan image. I think this one come from some sort like our chest, I think our chest, or our, because yeah, I think this one is come from our chest. Okay, cross section from chest. Okay, you can see, okay, as you can see that by applying by learning image enhancement, you manage to remove the noise and you obtain a good image. And after that, you also learned, after image enhancement, you will learn what we call as restoration, image restoration, which is this one. So image restoration is almost similar with image enhancement. The purpose is similar, okay, meaning that we want to the purpose of both image enhancement and image restoration is to improve the image in terms of the output image is quite good as compared to the input image, and the approach as well will manage to remove the noise which is make the radiologist difficult to observe something or to diagnose something. So that's why but the difference between image enhancement and image restoration is that image enhancement is doing a subjective approach, while image restoration will do in term by using what we call as objective approach. Okay, but that one later we will cover in each and every chapters. And after that, okay, you also learn about image segmentation. Okay, this one okay, so the image segmentation, the purpose of image segmentation, once you apply the image enhancement and image restoration, okay, this is the output after the image restoration. Then the purpose of segmentation, you want to highlight only the pixel belong to your region, to region of interest, okay, or to your object that you want to diagnose. For example, in this case, this is just a case, the region itself, we call it as a region of interest, is depend on your application. Okay, some people would like to define lung area as a region of interest, or might be blood vessel as your region of interest. It depend on the radiologist, but in this application, just assume that this point over here is your region of interest. This is the one that the radiologist would like to diagnose. So image in image segmentation, what you do is that you are separate the pixel into two things, okay, into two things, which is one is background, another one is object. The one in white is your object, the rest is background, meaning that any pixel that does not belong to your region of interest will become black, and any pixel that belong to your region of interest, then it will become white. Like in this case, this is I think is a iota or vessels there, so as our region of interest. So that is the purpose of segmentation. And then after that, okay, after segmentation, the last topic is morphological processing. Okay, morphological processing we can consider as a post processing after the segmentation, like I said before. For example, the purpose of image morphological processing is actually is like an image enhancement after segmentation. Okay, means that they enhance the image, or they try to try to uh, try to avoid, or try to okay, try to touch up the image a little bit. Because of course, if segmentation is something sometimes is due to the imperfection. When you are performing a segmentation, some part of the image actually is not, some part of the pixel actually is not the region of interest, but because of the imperfection of segmentation, then you or some errors happen in segmentation, then you also consider some point as your region, or some pixel as your region of interest. Like in this example, you can see that, okay, if I zoom in more there, okay, you can see that after segmentation, you find out there's a very sharp point over here. Okay, actually this is one of the error happens there. Actually that points, okay, this point over here, so it's very fine there, it's very small. Actually it's not pixel belong to your region of interest, actually it belong to background, but because of the limitation of your segmentation, that's why your segmentation process fail to define that one or two pixels there, which is should be belong to background, will be, actually it's belong to background, but now it's become object. So that's why now this is what happened because of the limitation of segmentation, which is why by learning the morphological, actually it will enhance at the post processing part, whereby applying the the process after the segmentation. Okay, this is the image after segmentation, which is similar to this one. This image, this image is similar to this one. Okay, but after applying morphological processing, you can see the comparisons there. Okay, that sharp point there, or that's very sharp there, have been removed after you applying the morphological, and that is actually improve and help a lot in terms of improving the accuracy, in terms of improving the performance of the system in terms of the accuracy, because you manage to remove the noise which is cannot be removed by the segmentation. So that is the last chapter, where what we call as a morphological processing, or it's also called as a post processing in image. Okay, so the what's thing you realize over here, each and every process over here is a continuous process. Okay, first you push the accusation, and then you want to remove the noise and improve the image quality. You applying image enhancement as well as image restoration. Then after that, you apply the segmentation for the purpose of to highlight the region of interest. Okay, and the last one, you applying the morphological processing, where actually the purpose is to touch up a little bit the image due to the poor quality of segmentation process. Okay, so here you can see that in any approach, in every step we apply here, the input, okay, what I mean is that in every process, doesn't matter is it image enhancement, in morphological processing, segmentation, you find out the input of each and every process is image, and the output of each and every process is also image. Okay, so that is, if you refer to some textbook, that is the definition of image processing. If you find out any process where the input is image, and after the process the output as well as image, that is actually is image processing. Okay, so why I try to explain in this way, because that is related to our previous definition, what is the difference between computer vision, image analysis, and image processing. Okay, now let's go back to this slide. Okay, let's go back to this slide. So now we go back to our discussion over here, how to define what is the difference between a computer vision, image analysis, and image processing. Okay, so this one I get some this actually is obtained from the Gonzalez textbook that we refer there. Okay, this is how they separate between image processing, image analysis, and computer vision. Okay, image processing is actually another name for image processing is a low level process. Okay, so that's why you can see at the low level process, the input is image. Any process that the input is image and the output is image, that is actually image processing. Okay, but image analysis, another name for image analysis. Okay, let me just give you some ideas there. This is image processing. Okay, this is image processing, and this is image analysis. Okay, image analysis is another name for image analysis. Is not another name actually. Image analysis is a middle level process, while the image processing is a low level process. So image analysis, the difference between image processing and image analysis, the input of image analysis, any process, if the input is the image and the output is attribute. Okay, attribute is like features of the image, like the parameter or the color in terms of figure and so on. So that is called image analysis. Okay, however, the last one, which is high level process, is actually called as a computer vision. Okay, this is actually computer vision. The computer vision, okay, sorry, this one is what have been defined by the Gonzalez textbook, but I would like to highlight the definition that I taken from other source, where actually the computer vision, the input should be image, okay, image, and the output is the understanding or interpretation, okay, interpretation, or it also can be the label of the image or the name of the image. So if you find out a certain process where the input is image and the output is the interpretation of the image or the label of the image or the name of the image, then that is called a computer vision. Okay, so that is the area, you can see that how to separate or how to make a border between image processing, image analysis, as well as computer vision.